And so we come to naming, not trivial naming, not the name dreamt up by some lunatic 200 years ago, but IUPAC naming, the International Union of Pure and Applied Chemists. Sounds impressive. Now, you might say that a rose by any other name would smell as sweet. Who said this course didn't have culture? But IUPAC naming is systematic. It should be able to name any molecule we can dream up today, and if it can't, we can add a new rule, and so it adapts. Thus, you really need to get to grips with the rules involved in IUPAC naming of a molecule. Put simply, it's locant, prefix, locant, parent, suffix. Simply? Okay, let's go into that a little more carefully. The first step to focus on is parent. In this part of the name, we let you know how many carbons are in the longest contiguous sequence. So that is one carbon after the next, without any breaks where other atoms might be in between. So once we've determined what the parent section is, so that might be a chain or a ring, it doesn't matter, the next thing we do is to look at what is attached to that parent section. We identify the functional groups, and then we determine their priority. The highest priority functional group goes to the right of the parent section in the suffix area. This is where we put that functional group name. Next, we want to describe where that functional group is on the main system. We give it a number, and that is placed immediately to the left before the parent section. Lastly, we want to look at all the other functional groups that happen not to be the highest priority functional group. We place those names in the prefix section, that is to the left before the number of the location of the highest priority functional group. Ultimately, we want to give the location for those functional groups. We will do that with a number that goes immediately before to the left of the prefix. Simple, right? Okay, let's look at some examples. Now, here is a molecule. The first thing we want to do is to work out the parent section. So in this case, it's a chain. What is the longest number of carbons uninterrupted by another atom? I can see 4. Oh, there's a 5. 5 is the longest here. So 5 carbons is the parent chain. But it's a name, so we aren't literally going to call it 5 carbons. The name here is going to be pentane. The pent section tells that there are 5 carbons in the parent system. Let's look at another case. Here I can see 5. Oh, hold on, there is 6. I think, yep, 6 is the longest system. It's a chain here, so we need to come up with a name that tells us there are 6 carbons in the parent chain. 6 we describe as hex, and so we're going to call this section hexane. So we have worked out the parent part of the molecule. The second step is to sequentially number the parent system. We want to make sure that one of the functional groups has the lowest possible number. The third step is to name the substituents that are attached to the parent system, and where they are not the highest priority, we need to list them in alphabetical order.